Hello everybody and welcome back. So in this lesson we're going to be talking about handles. So a handle is by definition an abstract reference to a resource, to an object or to a piece of geometry, right? So what does this mean for us? So basically, let me put it to you this way. I'm going to give you a bit of an analogy that might help understand what a handle does, okay? So if I had to say to you, go find the 10 nearest people to you. So the first 10 people you come across in the street and ask them their age, right? Then you come back with that information and then I say, okay, well now I need to know their height. So you would have to go back and find those 10 people again and query their height and bring that information back to me. And then I tell you, okay, well now I need to know their eye color and so on and so forth. You're running backwards and forwards, running the same operation, just returning a different piece of information, okay? And it would be much more convenient if I gave you a list of questions that I wanted, but that's not always possible. Sometimes I need to know something based on another piece of information, okay? So instead, what if I said to you, okay, well, go find the first 10 people and ask for their phone numbers. So now, when I ask for their height, you just phone them and ask. Then I ask for the age, you phone them and ask. You're querying again and again, but you're not having to do the legwork. You're not running backwards and forwards, finding the reference to those points. You already have a reference, okay? That is essentially what a handle boils down to, okay? So we have this kind of memory stored reference to a resource that we can then call in a very memory efficient way again and again and again. Okay, so let's talk about actual handles in geometry. So we have actually come across a few already, but the most simple form. So you may not even have noticed it. When we did our add point expression in the last lesson, you'll see that if I hit F1, so add point, it looks for a geometry handle, okay? So that's a handle, a reference, an abstract reference to the geometry, but in this case, we're just pointing to an input, you know, so we're saying everything coming into the first input should just be referenced. So it's going to essentially kind of cook this node coming in here, and then hold that in memory and then reference it within our vex script, okay? So that's just the most simple form. But what I want to talk about is a much more complex form of a handle, and this is where it's essentially an array of references. So each point is aware of multiple points. Like as I said in that example, I've sent you to find 10 people. So you're one person, you're one point, and now you have a reference to 10 people. And the thing is, when you gather their phone numbers, you also take a few notes as you're going. You take note of the order that you found them in. So you write the numbers down in a particular order, and you also note how far you traveled to find each person. And you write all that information down. So that's this much more complex handle. So then we can query a whole lot of information, including we can filter by something like the distance that it took to find them. So in other words, if we want to average the age of all the 10 people that you spoke to, but not just a mean average, but rather a weighted average based on the distance. So if a few people that were really close to you were very young, and then far away there's like a whole bunch of older people, because they're much further away, their age is going to count less in the average, and therefore the weighted average will come up a lot closer to the age of the people that are much closer to you. All right, so I hope you're following, but if you're not, don't worry, it'll make sense just now. So I'm going to talk about a PC open, right, which is a point cloud open. Okay, essentially we're performing a lookup into a point cloud and then creating a handle. And you'll see here it says it returns a handle to a point cloud file. Okay, so let's type this in, and then we'll see what we can do with this handle. So a handle is an integer, right? So we're going to create an integer variable, and I'm just going to call it handle. Okay, and then we're going to run our PC open. Now, actually, before I do this, let me just show you what I've got in my scene. Okay, so I'll disable this. So I've just got a simple sphere with some points, and then on this side I've got a box which I have painted some color on, and also given it a random foo value per point. So if I show you what foo looks like, that's represented like this, okay, and then the color that I've painted on here. Okay, and then we have our piece of geometry there, and what we're wanting to do is essentially reference this geometry by proximity, and that's exactly where a PC open is going to be very useful. Now you will see similarities between this function and the PC find that we used in the previous few lessons. They have similar arguments and they do something similar, although that one does not return a handle, it just returns a list of point numbers, okay? But that one's a lot more of a simplified form, and then also in order to reference those point numbers you have to use much heavier operations. And then one of the other downsides as well is it doesn't have this ability to reference a file name. So here we can reference an input, we can do a PC lookup within our scene. But what's very powerful is you can also read something from disk. So often we will create a point cloud on a character, with a particular kind of attribute stored on all of these points. So it's independent of the amount of geometry that's on there. We just scatter points, and then we have these this attribute stored in all these points, and then that is cached out to disk. And then at render time in our shaders, you actually use a PC open and you read in that point cloud, and then each pixel on the geometry when it's wanting to render it is looking up at that point cloud that you're importing to find that attribute. So then that's how you can create very detailed masks, reading in weird kind of stored custom attributes. So it's very, very useful. Okay. In fact, we'll probably do an example like that later on, just so you can kind of see what I mean, because it's something we use quite often. Right. So let's build this handle. Okay. So we've got our PC open. We're going to reference an input. So obviously we're just going to say 1 because we're wanting to reference our second input. Then we need to give it the P channel. So this is the position channel that we're wanting to read from the incoming geometry, which is P, okay, capital P for position. And then we want to reference the actual position where we want to read from. So in other words, on our incoming geometry, so on our first input, where is the position we want to read from? We could read from one particular point, or sort of per point we could calculate another location to read from if we want to maybe extend out along the normals or something. But in this case, I just want to read from my current position, so I'm using v at p. And then we're going to feed it a radius to search within and a max number of points. So I'm just going to do this with a channel. Okay, so channel float radius and channel integer max PTS. Okay, and then close all of that, semicolon. Okay, and then when I run this, then we can also choose our radius. So let's just say 0.1, and our max number of points, let's set it to 5. We'll check if this radius is enough later. Okay, so there we are. We now have a handle, and although you won't see any actual difference, this is our reference now. So essentially we've gone and collected the phone numbers. So now we can start phoning and gathering all the bits of information we want. Okay. So the first and easiest way to do that is with okay, don't be intimidated by this massive long name. It's a PC import by idx, so index, and then f for float. Now this function has multiple types, and rather than how a lot of other vex functions work, where depending on how you typecast it, it will just figure out, like it's an overdriven function, and it'll figure out what type you want. Instead, with this, there are a full range of, so if I type here PC import, you'll see here PC import by index 3, which is a matrix 3, or matrix 4, float, integer, quaternion, a string, and a vector. Okay, so there's for all the different types, you have to run a different function. Okay. So the one we're after is a PC import by index f, because we know that we're wanting to import our foo attribute, which is a float. Okay, I'm just starting with a foo because the float is easier to do, and then I'll show you the vector as well. Okay, so what we're doing with PC import by index is, remember I said we're going to keep track of the order that we find the people. So your 10 phone numbers have an order, the same as an array, right? It has 0, 1, 2, 3, 4, up to 9, okay? So here what we're doing is I'm saying to you, phone person number 3 and ask them their age or whatever it is, okay? Ask them their foo. And so it has nothing to do with all the others, it's just based on the number that you came across that person, and then you phone that one person. Okay, so we're just grabbing one piece of information. Okay, so I can store this, so we know it's a float, so let me just say f at foo equals, so we're going to store it in our own foo attribute, and put handle, and then we give it the string to the channel name, so the channel name is foo, and then index. So if we just say 0, it's going to find the closest point to us, its foo value. Okay, but it's going to find the closest point only if that point exists within the handle. In other words, does it fall within the radius and the maximum number of points? Okay, so if we've told it 5 here, but we tell it to go find index 10, it's going to return nothing. Okay, so now what we'll probably find on here is that we have no foo values. On our sphere we have nothing because our radius is not wide enough. But as soon as our radius is, you'll see there that we're transferring values. Okay, and as the values spread, you'll see that here nothing's changing, even though we're spreading further, because it knows its closest point, and that's all it needs. Okay, these values over here are just outside of the radius, but these ones over here, once they found their closest point is always going to be their closest point. Okay, so there we have it. And let's do the same thing with our color as well. So you'll see that we can just say v at cd equals PC import by idx v for vector. Then we reference our handle, and then cd 0. Okay, and you'll see there it's grabbing color, right? And we can change this number, so you'll watch what happens if we change this to 1, and you'll see there it changes, and then 2, 3, 4, 5. And now you see when we go to 5, because there is no index 5, because we've said there's a maximum number of points as 5, and they start from 0. But if we increase the max points, now this will increase again, and we can take this all the way up to 9. And you'll see when we start going up to 9, we're actually starting to get a little bit of this red that's at the back here coming through. And the reason for that is because this one is finding its nearest 10 points, and then but we're saying grab the 9th index, so right at the end of the list, go and grab that, and so it's grabbing a kind of an orangey value from probably somewhere over here. All right. Okay. So this is PC import by index, and it can be very useful, but often the reason we have a whole array of points gathered in here is because we want to filter them in some way, or check an average or a maximum or gather some more complex data than just one single point, because otherwise then we would normally just say max number of points 1. Why process 10 points if we don't want to find that one closest point? Okay, so let's use a PC filter. This is our next function that we're going to be talking about, and I'll open up the help card for the PC filter. So PC filter is going to basically, it's going to gather all the information within that handle of all the points, the max number of points that fell within that radius, and it's going to filter it. It's essentially going to give us a weighted average. It even explains here what the function actually roughly equates to. So if you want to practice, you could even rebuild this function in Vex and kind of play around with it. Okay. But essentially it's sort of weighting it based on the distance to that point. Now we're going to come back to this just now, so don't worry about this too much, but I'm going to explain how we can gather the distance of our points as well. But anyway, it's using distance as a way to then average out. So if you could have loads of points that have a value of 10, but then one point that's very close to you that has a value of 0, and it will it'll be much more biased towards the 0, even though there's multiple points that have the value 10, because they're very far away. Okay, so that's what the PC filter is doing. So simple arguments, we just need to give it the handle and the channel name. All right, so we feed it our handle and the channel name. So let's just reference CD. Okay, it's a lot more fun to just see the color. So I'm going to store it in our color and see what happens there. So you can see how blurred this color is. Okay, so it's grabbing all of its 10 points and filtering them. Okay, and you'll see that the red has kind of disappeared out of that, even though we are finding loads more points. And let me increase this radius as well, because the closest colors to it is green. It's going to be much more biased towards picking up the green than the red at the back. Okay. And if we decrease the number of points, though, you'll see that these values sharpen, because it's obviously only grabbing the first closest point. So at 1, a PC filter is basically the same as a PC import by index, because there's only one thing to gather. Okay. But as we start increasing the number of points that it processes, then it's going to blur this value out as it transfers it. Okay, and then if we move our sphere over to this side, then you'll see we'll gather much more of the red values. Okay, right, so now let's move on from that. So sometimes this is going to be enough for you to just import a single index or filter it. But what if you don't want to filter it this way? What if you want to change the way that it's weighted, or maybe just gather the maximum of what you found or the minimum, right? So instead, what we're going to want to do is actually iterate through our points, through our handle, open it up, take one point at a time, gather one bit of information from that index, and then continue to the next one, right? So instead of having to loop and then just use our PC import by index and then increment the index every time, there's just a much simpler way of doing that. Okay, so we're going to use a function called PC iterate. And PC iterate has basically just been designed for this exact purpose. Okay, it says this function can be used to iterate over all the points which were found in the PC open query. Okay, and you just feed it a handle. And what it's going to do is you're going to put it inside of a while loop, and it's basically just going to return 1 every time, like every increment, until you've gotten through all the points in the handle, and then it will return 0. Which, remember, our while loop is going to keep looping until the condition becomes false. So PC iterate is doing exactly that. Measuring how many points we have in that handle per point, which will be different. Remember, points close here will have all 10 points. A point that's really far on the outer edge of the radius may not actually be gathering 10 points, because there may not be 10 points within this radius of itself. Okay, so per point, it's going to figure out how many points there are, and then this is going to return true, 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 and then suddenly false when it has gotten through all of the points. Okay, and we're going to put this inside of a while loop. So this will be the condition for the while loop, and then we just open our block. Okay, so now inside of this loop we can do whatever we want, and inside of a PC iterate, we're going to use a function called PC import. Okay, and this is going to allow us to grab a value of that particular point that we're processing and then do something with it. Okay, so you'll notice that this, okay, it is returning an integer, which I think will probably be saying essentially whether it is has successfully yes, returns 1 if the import was successful and 0 if it failed, right? So this is not necessarily a value that we need, although we may want to check it. But the actual value of that channel is being stored in here. Remember this ampersand sign? So we have to initialize a variable before we store it in here. So we would just say something like vector col or something. We can call it whatever we want. And then we're going to say PC import. We're going to give it our handle. We're going to give it the channel name. So we want CD. And then we're going to feed it col, where it's going to store the value. And for the purposes of this, let me also say int success equals. Okay. So now success will be 0 or 1 depending on whether it successfully found this value on that point in the handle, and col will have been filled with the value, right? So now what do we do with that though? How do we get this value out of here, right? So we've stored it in col. Well, so what if I go outside of here and I say, well, v at cd equals col, and it's going to error out, okay, saying that we're referencing an undefined variable. And that's because, and I remember I showed you this last time, the col has been initialized inside of the block here. Okay, so it's only going to live and exist within this block. Now sometimes that's what we want. We want to actually just create a variable to temporarily store this value and maybe have that value interact with maybe our foo value, and then we'll output a certain value. So, like a different variable. So that's fine. This can be useful. But in this particular case, because we're wanting to just directly import this, I actually want to store this outside. Okay. So if I store it outside, then it will find it here because it exists before we enter the block. Inside the block it does exist because blocks do import everything that's on the outside. We overwrite that value and then we're setting it on the outside over here. Okay, but this will essentially equate to finding the PC import by index with the last index, because what it's going to do is it's going to loop through the points that it's found, and let's say it's got 10 points. It's going to, on the first point, import its color and set color, but then, well, it's going to initialize it to 0. Then inside this handle, it's going to find the first value, then move over to the next point, find the second value and overwrite the first one, and then the third point and overwrite it. So it's going to keep overwriting that value until the last point. So we're basically finding the value of the last point, and that's not what we want to do. Instead, we want to maybe average this out somehow. So let's try and store this color value of this point and compare it. Let's add them all together, all of these color values, and then divide it by the number of points or something like that. Okay, so let's go over here, right? So we're going to create an integer count, okay, and initialize this to 0. Right? And this is because we want to find out how many times we're looping in this while, because that's what the number we're going to want to be dividing by. Because remember, to average something, you just add it all together and then divide by the number of items. Okay, so we need to count. So we're going to start at 0, and then every time inside of this loop, we're going to say count plus equals 1. All right, so then we're going to use that as our divisor. Okay, and then we're importing this color attribute, but maybe what we should do is store it. Okay, so we need to add them all together, right? So coal is actually going to be our final color, but we're going to want to actually create something like a vector, add coal or something like that. Okay, and then we're going to store this value in the add coal instead. So just inside of here, we're just storing it, and then we're going to basically just so let's do this. So because coal already exists, we're going to say coal plus equals add coal, right? So we initialize the variable, so this will be blank every time we enter this loop, and store that value. We're then adding that value to coal, which was 0, but now every loop we're adding. So essentially we're adding all of our color values together. So it's going to end up being very bright. And then we're going to divide at the end though. So once we exit this loop, we want to take coal and divide it by, so divide equals count. Okay, and then when we set CD to equal coal, then we're getting this basically averaged color. Okay, so it's a similar kind of effect to what the PC filter did, although it is actually different because a PC filter is weighted by distance. Here we haven't included the distance at all, which if this is what you want, then great. So this is actually essentially my point, is that sometimes you're going to want to PC iterate and control the way that you average. Okay, instead of adding them together every time, what we might want to do is actually say coal is equal to the maximum of our additional color, so our new color, and our old value. So therefore we're actually just taking the maximum. But then when we take the maximum, we wouldn't want to actually count and do that. So because there's some white values in here, any of these that are finding a white value are going to keep that value because it's the it's 1 on R, G, and B. But over here we get a bit of green because this green, all of its 10 points that it's finding are green or blue or something, like it's not finding any white value. So therefore we actually get a little splash of green here. So this is taking into account the maximum. Also, you'll see here, there's a good example on the edge, this point, because it's searching this radius and it's right on the edge of that radius. It's told to find a maximum of 10 points, but it's probably only finding 1. It's just grabbing one of these points over here, and the maximum value is obviously just blue. Okay, so you could take the maximum, you could take the minimum, right, which is just going to be 0. But you know what I'm saying. You guys can essentially just build this average any way you want. You could import that foo value that we had as well, and maybe compare foo to color, and only grab the color if the foo reaches is a certain number or above. So there's lots of cool interactions you can do inside of here. Now, the one thing that's very important to note is that these handles are very memory efficient. That's not to say that they're free. Yes, if you do this with 1,000,000 billion points, then it's gonna still struggle, but it is much lighter than most other proximity queries. So I always try to use a wrangle node with a PC open instead of the attribute transfer node. This attribute transfer also works by proximity, and this has got, it's a much heavier operation, and there's so many other features built into it that you don't necessarily need. Sometimes I'll still use it because it is exactly what you need, but more often than not I'm finding that the PC Open does exactly what I want and more, and it's so much lighter. But the only thing is you just need to know exactly how to type it out, which, you know, I've just explained how. So if you guys can memorize this, this will save you a lot of power later on. Okay, so very, very light. Now, before we move on and end the lesson, I just want to explain one more thing, and that's that you can search. There's two special attributes that you can actually search for, right? And it lists it under the PC import, but you can use it in PC import by index, you can use it in PC filter, any of them. So there's two different special channel names, point.number and point.distance. Okay, so that is returning the index of the number in the handle and then the distance to that point. Okay, and these two can be very, very useful, right? If you're just wanting to do a proximity check, so you're wanting to check whether this has come within the radius of this box. Maybe you're checking for collisions or something like that, or when this sphere comes near the box, you want to start emitting points or something like that. You would then just use a PC Open, but then you would maybe a PC import by index, and so let's actually do that. We'll do a f at dist, and I'm going to say PC import by index f, okay, because it's a float value that we're wanting to store. I'm going to say handle, and then I'm going to say point dot distance, point dot distance, and then 0, right? So we're importing the first point that we find. So essentially this is returning the minimum distance that that it's going to find on this, on this neighboring piece of geometry. Okay, so here we have a dist, and in fact we can I'm gonna visualize our dist over here. So now you can see these values at the back are getting a 0 because they're not finding any handle, so they're just defaulting to a dist value of 0, which would be the default of this. Okay, then these have white values because they're very far away from here. Just hit spacebar. Okay, and then the points as they get closer and closer to the box have lower and lower values. Okay, so this is very useful in finding how far away is this geometry from this geometry. But the problem is this boundary where it flips from very high values to very low values. Okay, because here, like I said, if this point was touching this piece of geometry, you'd get a value of 0. But these values on the back are also 0. So how do you differentiate between these two? All right, and the way we're going to do that is with I'm just going to say I at idx. Okay, so for index, all right, and I do PC import by index I handle, so we reference our handle, and then we use the other one, which is point dot number, and again we're going to use 0. Okay, so our index number here is returning -1 when it has not found any points in the handle, and then whatever the point number of the point is that it's found. Okay, and this here, this boundary between these negative values and positive, is what we need. We actually, in this case, we don't care about what the point number actually is. We just want to know whether the point number is positive or negative, because this -1 denotes an error, and that will differentiate our 0 over here. Let me actually move this a bit closer so we actually have a 0. Okay, so we'll move it right on top of it, and then I'm just going to reduce the radius a little. Okay, so we want to essentially have a fall off from 0 to 1 here, and then it must stay 1 because these points are all just super far away from this, right? So we would then say, so I would actually rather store this in a dist like that, and maybe do this, and then I'd say f at dist equals if idx greater than 0, or greater than or equal to 0, okay, because it may be 0. Remember that it may find the point number 0, so be careful. You must say greater than or equals to 0. So in other words, it's not negative. So if it's not negative, then dist is equal to our dist attribute, else f at dist equals 1. Okay, and now we get a perfect gradient. So sort of starting from 0 here, going up to 1 at the radius. So this radius over here, and then onwards. Okay. Oh, in fact, sorry. Let me actually point something out here. It'll only be 0 to 1 if this radius is actually 1. Okay. But what if we're searching a really small distance, like 0.5? Then there's going to be a bit of a sharp fall off here, because we're going to have values going from 0 all the way to 0.5, and then suddenly jumps up to 1. What we should do in here is fit our dist between 0 and our radius channel. So this channel over here, because we know that's how far we're looking. So we fit between 0 and that value, and we fit it to a value of 0 to 1. Okay, and now we'll get a perfect fall off gradient. So 0 at the tip all the way to 1 where it's at the maximum radius here, defined by this value, and then 1 onwards. Okay, and then as we increase this, so now you can use this for all sorts of proximity queries. As things get near to a surface and it starts emitting points or something like that. Okay, I mean, we could even scatter based on that dist. So you'd scatter, but then you have a density which would be dist. Okay. Oh, remember it's a 0 here and 1 on the other side. So obviously you may want to go and invert that value if you want to do something like this scatter. So over here you'd say f at dist equals 1 minus at dist. Okay. And now I see we're scattering points only when we get near this. And in fact, it is weighted, like, you know, the closer to 0 we get, the more points we actually have. Okay. Right. So there we have it. Handles are very, very powerful. Yeah, I'm sure you'll use them a lot, but also don't be afraid of using them. Okay, don't avoid them just because there's a few steps, a few lines of code. You know, you've got to create the handle first, then filter them or iterate over them. It takes a little while to learn the syntax and how to write this, but it is so much lighter than attribute transfer or a whole lot of other proximity queries. So please try to use it. Okay. All right, guys. So thank you very much for listening, and I'll see you all in the next lesson.